Hello learners, welcome to your favorite e-learning platform Pathshala. I am Savita Chauhan, your mathematics mentor. Let's just start a new chapter today which is called as the Heron's formula. So let's just start with it. First of all, as we have already discussed about the figures of the different shapes, like if I'm talking about the squares, if I'm talking about the quadrilaterals, or if I'm talking about the triangles. So we are already aware about all such kind of shapes, and we have discussed all these kind of shapes in our previous classes. So let us suppose if I'm asking you that how we can find out the perimeter and the area of all these figures, then you can obviously able to find the perimeter and the area of such type of figures. So let us suppose if I'm asking you that there is a particular classroom, and I'm just telling you to find out the area of the floor of this particular classroom such that the floor is rectangular in shape. Yes, it's rectangular, and let us suppose the length and the breadth of this particular floor is given to us as nothing but 10 meters and width is nothing but 8 meters. So it means that the area we just wanted to find out is nothing but an area of the rectangular floor such that the length of this particular floor is nothing but 10 meters and the breadth or the width of this particular floor is nothing but 8 meters. So let's just start finding out the area of this particular rectangular floor. First of all, we know that the area of rectangle is nothing but is equal to length into breadth. Yes, the area of the rectangle is nothing but is equal to length into breadth. So let's just substitute the value of length as 10 meter and breadth as 8 meter in this particular formula. So if I'll substitute length as 10, breadth as 8, then we get the answer as 80 meters square. 80 meters square, because the measurements that we have is nothing but 10 meters and 8 meters. So the unit that we are using over here is nothing but meter square. So it means area is nothing but is equal to 80 meters square. Now let's just talk about the perimeter of this particular rectangular floor. So first of all, it is a rectangle. So the perimeter of rectangle is nothing but 2 into length plus breadth. This is nothing but the formula to find out the perimeter of a rectangle. So as this is nothing but a rectangular floor, so for it the perimeter is again the same, which is 2 into length plus breadth. So let's just substitute length and breadth in this formula. So if I'll substitute length as 10 meters and breadth as 8 meters, then the answer is nothing but 2 into 10 plus 8, that is 18 into 2, which is nothing but is equal to 36 meters. So unit of measurement again is nothing but meters. So the answer for the perimeter is nothing but 36 meters. So this is quite an easy thing for us to find out the area and the perimeter of such a type of figure. So let us suppose if I'm just moving on further with the same concept of finding out the areas and the perimeters of such figure. So let us suppose if I'll ask you that how we can find the area of a right angle triangle. If I'm asking you that how we can able to find out the area of the right angle triangle, so let us suppose if I'll take a right angle triangle over here. As you can see, this is nothing but a right angle triangle, and we have two things given to us, which is nothing but the base and the height. So the base is nothing but 5 meter and the height is nothing but 12 meter. So for an instance, if I'm saying if in this particular right angle triangle we do know about the length of the two sides as 5 centimeter and 12 centimeter, then are you able to find the area of this particular right angle triangle? So yes, we know that if we have a right angle triangle whose two sides are actually given to us, then we can find the area of the triangle with the help of a particular formula, which is nothing but called as area of triangle is equal to half into base into height. So this is only applicable if we know the two consecutive sides which do have a 90-degree angle between them. So as you can see over here, these are the two consecutive sides that we do have, and there is an angle of 90 degree in between these two. So if we know such a type of the measurements for any particular right angle triangle, then we can find the area of the triangle with the help of this particular formula, which is half into base into height. So you can take any particular measurement as base, or you can take any of them as height. So let us suppose if I'm taking the base as 5 centimeter and the height as 12 centimeter. So let's just substitute in this particular formula and find out the area. So let us suppose if I'm substituting the base as nothing but 5 centimeter, as I'm considering this as nothing but base, you can consider it as a height as well. So let us suppose if I'm taking it as a base, if I'm taking it as nothing but a height, so let's just substitute the value in this particular formula in order to find out the area. So as you can see, we have half into base. What is the base over here? Base is nothing but 5 centimeter and the height is nothing but 12 centimeter. So let's just sort it out. So it is 2 into 1 is 2, 2 into 6 is 12. This is nothing but 5 into 6, and 5 into 6 is nothing but 30 centimeter. Centimeter, obviously we are finding out the square, so we have centimeter square. Hence at the end, the area of this particular triangle, that is a right angle triangle whose two consecutive sides are given that are having an angle of 90 degree in between them. If we are finding out the area of such type of a triangle, so this is nothing but is equal to 30 meter square if the two sides are nothing but 5 centimeter and 12 centimeter. So this is how we can find the area of such a type of a triangle, which is nothing but a right angle triangle. So let us suppose if I have another type of triangle, then how we can find the area of that triangle? Let's just see. So let us suppose if we have an equilateral triangle and we just wanted to find out the area of the equilateral triangle. As we know that the equilateral triangle is a triangle in which all the sides are equal in measure. So let us suppose if I'm having this particular equilateral triangle such that the side of the equilateral triangle is 10 centimeter. So I have already done a construction over here that I have drawn a PM perpendicular over here. This is nothing but a perpendicular to QR. So this is nothing but a perpendicular to the QR. So I have already drawn this particular perpendicular on the QR. So as we know that the side of this equilateral triangle is 10 centimeters. So if this is 10, so obviously this is nothing but also 10 centimeter. Moreover, this is nothing but also 10 centimeter. But as I have drawn a perpendicular over here, so this will divide this QR into the two equal sections. So it means that this is nothing but 5 centimeter, and further MR is again nothing but 5 centimeter. So let's just find out the area of this particular triangle again. So as we know that if this is nothing but a perpendicular, then this is nothing but the height of the triangle. This is nothing but the height of the triangle. So let us suppose if I am finding out the area of this whole triangle, so this would be nothing but area of the triangle, PMQ. Let us suppose if I am finding out the area of this particular triangle. So if I'll find the area of this particular triangle, then this area and this area will always be equal to each other, because as we know that this is nothing but an equilateral triangle. So the area for this section would be equal to the area of this section. So let us suppose if I am finding out the area of the triangle PMQ, as it is nothing but a right angle triangle, so I can able to find it with the help of half into base into height formula. So this would be nothing but half into base into height. So you can take the base as 5 centimeter. So I am taking the base as 5, and further as we just wanted to find out its height, but we are not having this height, means we do not have the measurement of this particular height, PM. So let us suppose if I am writing over here half into base is nothing but QM, and we do not know about PM. So let's just calculate PM. How we can able to calculate PM? As you can see in the triangle PQM, in the triangle PQM or PMQ, we know that by Pythagoras theorem, we can able to find out the third side, because with the help of Pythagoras theorem, we can say that hypotenuse square is nothing but is equal to perpendicular square plus base square. As we have the perpendicular over here as PM, the hypotenuse is 10 and the base as nothing but 5. So let's just substitute all these values over here. So first of all, we have hypotenuse as nothing but 10. So this is 10 square, which is equal to perpendicular. Let us suppose if I'm calling it as PM whole square, and base is nothing but 5 square. So this would be 100, which is equal to PM square plus 25. So let's just take this 25 toward the other side. So PM square is nothing but is equal to 100 minus of 25, which is actually nothing but 75. So it means that PM is nothing but square root of 75. This is nothing but square root of 75. And furthermore, we can write it as nothing but 25, and we can write it as the factors in the form of the factors. So PM is nothing but is equal to square root of, as we have 75, so we can also find the factors of the 75. So let us suppose if I'm finding out the factors of 75 and I'm writing under the square root as nothing but, as we have the 75, which is nothing but 5, and further we have 5 into 1 is 5, we have 5 into 5 is 25, we have 5 and 3 is 15, and further we have 3 and 1. So it means that we can write it into the formation of 5 into 5 as it is coming 2 times. As you can see, 5 into 5 into 3, in which we have 5 which is coming exactly at 2 times. So let us suppose if I am writing it into the manner as 5 into 3 into 5, and further if I am taking 5 and 5 common out of the square root, then this would be nothing but is equal to PM, which is equal to 5 square root of 3. So it means that PM is nothing but is equal to 5 square root 3. Hence, the height of this particular equilateral triangle is nothing but 5 root 3. So let us suppose if I'm mentioning it over here that the height is nothing but 5 root 3. It is 5 root 3. So I can able to find the area of this particular triangle by substituting all the things in this particular formula. So let's just substitute all the values over here. So as we have the area of the triangle, let us suppose if I'm continuing over here, the area of the triangle PMQ is equal to half into QM. The value of QM that we have is nothing but 5. Further we have PM. What is PM? PM is nothing but 5 root 3. So this is nothing but the area of the triangle PMQ. And obviously, if we are talking about the area of the total triangle, that is PQR, it implies the area of the triangle PQR should be equal to the twice of the area of the triangle PMQ. This should be equal to twice of the area, because the area of the triangle PQM is just as same as that of the area of the triangle PMR. So this would be nothing but 2 into, let's just substitute this value over here. This would be half into 5 is 25 root 3. So 2 and 2 get cancelled. The answer is nothing but 25 root 3, because it is the units that we have is nothing but centimeter. So this would be centimeter square, and hence this is nothing but the area of the triangle PQR, which is actually an equilateral triangle, and hence the area for this triangle is nothing but 25 root 3 centimeter square. So using the formula again, that is half into base into height, and using the Pythagoras theorem, we have calculated the area of the equilateral triangle. So let's just move on further and talk about how we can find the area of an isosceles triangle. Now let's just find out the area of an isosceles triangle. So let us suppose if we have an isosceles triangle of this particular form, such that in the isosceles triangle we do know that the two sides are equal to each other. So let us suppose the measurements are given to us as nothing but 5 centimeter, 5 centimeter and 8 centimeter. So in order to find the area of this particular triangle, again we are using the same formula, which is nothing but half into base into height. So let us suppose if I am drawing a perpendicular from the vertex P towards the vertex, towards the side QR. So let us suppose if I am drawing a perpendicular over here. So if this is nothing but a perpendicular, then it will divide this QR into the two section, because in the previous case we have also taken a perpendicular, but that perpendicular was in such a way that the point M was the midpoint of the side QR. In the previous section, the M point was the midpoint of the side QR, but here we have drawn a perpendicular from P towards the QR, and let us suppose if I'm calling it as M. So this will divide this whole side into the two section again. So this would be nothing but 4 centimeter, and again this would be nothing but 4 centimeter. This is again of 4 centimeter because the total was 8 centimeter. Now if we just wanted to find out the area of this triangle, then we can able to find it, because we know that the area of triangle is nothing but half into base into height. So rather than finding out the area for the single one, here I am finding out the area of the whole as half into base into height, as we know that it is nothing but is equal to half into base is nothing but QR, and height is nothing but PM, so we do know that the base QR is nothing but 8 centimeter, but we do not have the height PM. So let us suppose if I'm finding out the height PM using the Pythagoras theorem again. So in the triangle PQM, we know that PQ square is equal to QM square plus PM square. Hypotenuse square is equal to perpendicular square plus base square. Let's just substitute all the values over here. This is 5 square, which is equal to PM square, we do not know, plus QM is nothing but 4 square. So this is 25 minus of 16, which is equal to PM square. So this would be 9 is equal to PM square, and the value of PM is nothing but is equal to 3, because root 9 is nothing but 3. So this is nothing but 3 centimeter. Hence we know the height of this particular triangle is nothing but 3 centimeter. So let's just substitute all the values over here. So the answer would be half into 8 into 3, because the base is 8, the total base is 8, and the height is nothing but 3. So 2 into 1 is 2, 2 into 4 is 8, so this is nothing but 4 into 3, that is 12 centimeter square. So this is nothing but the area of this particular isosceles triangle using the formula again, that is half into base into height. Now let's just move on further towards a new condition.